In this video, I'll explain to you the ruby laser and the helium neon laser. For the ruby laser, there's a xenon discharge lamp which optically pumps the electrons or atoms to the higher energy state, and in the ruby rod, we have the components required to emit the lights of the required wavelengths. The ruby laser is a 3-energy lever which functions in the way we have discussed. First, pumping is achieved by the use of xenon flash lamp to produce light of the right frequency, and this is called optical pumping. This pumping excites the chromium atom from the ground state E1 to the state E3. The wavelength absorbed is 545 nanometer, which corresponds to green light. Here we see the green light photon coming in, exciting the electron or atom from the ground state to the excited state. Then there is a non-radiative transition, which is a spontaneous emission, allowing atoms to acclimate in the metastable state E2. Sometimes one atom will spontaneously de-excite, which will allow a creation of a photon of 694 nanometers. This photon will bounce around the laser cavity, which will allow more stimulated emission. The atom stays in the excited state E3 for a short time, right? Because before de-exciting to state E2, right? And if we remember the energy levels, they are previously 1.79 in energy E2 and 0 in ground state. This allows us to calculate the difference in energy level, which is 1.79 eV, which then allows us to calculate the energy of the photon. Using hc over lambda allows us to calculate the wavelength of the photon to be 694 nanometers, which is in the red color zone. Next, we have the helium neon laser. In the helium neon laser, there's a helium neon gas reservoir, and pumping is achieved by electrical discharge, accelerating a stream of electrons between the cathode and the anode. These electrons collide with the helium gas and excite them to the metastable state, which has an energy of 20.61 eV above the ground state. This is close to the excited state of neon with 20.66 eV. However, there is a difference of 0.05. This difference is made up by the kinetic energy of the neon itself, making up for the shortfall. Here we see the energy level diagram. You see that there is a difference between the excited state of helium compared with the excited state of neon. Once the collision is done, neon is at the excited state, and there will be a stimulated emission from energy level 3 to energy level 2, causing an emission of light at 633 nanometers. This steady input energy via electrical discharge and the collision between helium and neon atoms ensures a constant state of population inversion needed to sustain the lasing action.